one scale. Like if you say, like, what proportion of our planet's power are we harnessing? It's a very, very tiny number. And basically we're harnessing almost nothing of our star's power. So the sun is truly an immense thing. It is difficult with words to characterize just how immense the sun is, but this gives you sort of a sense of scale.
Yeah, it's a big difficulty jump going from level 1 to level 2.
Very big difficulty jump, yes. And level 3, and we don't even know how to do level 3, really.
We'll get there.
Yeah, exactly. AI will figure it out, I suppose. One way to appreciate the size of the sun is to think about how heavy is the sun compared to all the rest of the mass in the solar system. So the sun is about 99.86% of all mass in the solar system. It's everything, and then of the remaining 0.14%, most of that is Jupiter, one planet.
So we're still lightweight.
Yes. The entire mass of Earth is in the tiny miscellaneous category. We're like Earth is a tiny dust mote compared to the sun.
Well, but how much energy are we talking? Like coming from the sun, especially compared to what we're using here on Earth? Because it feels like...
Yeah. The incident solar energy on the cross-section of the Earth is roughly a half-billionth of the sun's power output. And the vast majority of that we cannot use because 70% of Earth is water.
Yeah.
Technically, our planet should be called water because it is 70% water, and I think an alien civilization visiting us would be like, why are they calling it Earth when it is mostly water?
We're the Greenland's not green of the solar system.
Yeah, a bunch of exactly even we're 70% water, and then of the 30% that's land, a bunch of it is Antarctica or Siberia type of thing, very northern Canada type of thing. Very difficult to not places people typically want to live, and you're not going to get a lot of solar power at the poles. So the actual usable area of land where you can get solar power is quite small. Anyway, in order to ascend the Kardashev scale, or in order to get to any meaningful percentage of the sun's energy harnessed, you have to go to space. If you wanted to get to, say, a millionth of the power output of the sun, you would have to increase civilizational energy harnessed by much more than 1 million. So we currently use much less than 1/trillionth of the power output of the sun. And 1 trillion is 1 million times 1 million. So basically, we're basically practically nowhere on the sort of the Kardashev 2 scale, practically nowhere.
So on Kardashev scale, we're all still we're still
non-existent.
Failing.
We're not registered. We're like not we're not even. Yeah. We're not registering.
Not even a microsol.
Yeah.
No.
And so to actually...
One microsol would be an epic achievement relative to where we are right now.
Something to aspire to.
Yeah. Yeah, that's our goal. And this is, I think, both simultaneously an incredibly adventurous goal relative to where we are, and yet not particularly adventurous as a percentage of the sun's energy to try to achieve power harness being 1 millionth of what the sun outputs.
And so to actually start...
A microsol.
Yeah. To actually start getting there, though, we're not just going to throw solar arrays in space, try to soak up a bunch of the sun. Like, there has to be a need. Like, you want to go up there and do something meaningful. And obviously, until this point in human history, like, there hasn't really been a need. What has changed to make us think that, like, maybe now's the time to start trying to notch a percentage point or two?
I mean, getting to 1% of the sun's energy?
Maybe not 1%. Let's go, like, we'll move the decimal point back.
So you're an extremely kick-ass civilization if you get to 1% of the sun's energy. And I'm like, wow, that civilization is going to be vastly more powerful than us, to say the least.
Yeah.
So in order to start to make some progress on the Kardashev scale, we need to